Okay. Okay, now, again, remember, please don't speak or walk in front of the camera. While the video is on. Okay. So. We start with 4 simple fractions. Took most of you 2 minutes to do them all, okay? Right down through. You did them as fast as you can write them, okay? Because you know how to do this. Of course, we're going to talk about why you do what you do. And why we're starting with 5th grade arithmetic. Well, number one, because everybody pretty much knows how to do this. Not everybody coming into pre-calculus class, but almost everybody get these right. Okay. So this is a skill that people have, but you get a little further into fractions and people can't do the arithmetic. Okay. 90% of people come into pre-calculus can't do fractions. Okay. That they can do this, and they can do a couple other things with it. Okay, and why is this really important? It's really important because in pre-calculus, you have to be able to deal with fractions that consist of symbols. And that's where people get lost. It turns out that the things you do with functions, and we haven't defined functions, but you deal with functions in pre-calculus. And those functions that are defined by fractions with symbols, first thing in the course for most people. Okay, they don't have a foundation of fractions. Just had a really good class last semester, but that particular aspect of the course, they were terrible, and they were really good at just about everything else. So I'm not insulting them because they were hardworking. They were here all the time. They're a wonderful group to work with. They couldn't get it. Okay. Partly because it was late in the semester and they probably had other things because they were able to do it in class, but they weren't able to do it in the exam. It goes back to not understanding fractions, okay? And that's just that class. I pick on that class because it's one of my best classes, one of my best pre-calculus classes. So I'm complimenting them because they're a great group. But even those students fell on their faces and it came right down to it, okay? So we don't want that to happen, so we're going to do fractions. The other thing we're going to do in this course is, depending, because it's a small class, smaller than usual, maybe less than half the size than usual, even if everybody shows up. Okay. There are a couple of people don't see here today, but sometimes that happens in the first day. Okay. Depending on what I see as I assess the skills of the class, we're going to almost certainly have to spend usually in this class. Okay. You all look pretty good so far. We haven't done all that much. Usually in this class, I have to spend half the semester doing algebra 1. Supposed to be doing intermediate algebra, that's algebra 2. Can't do that because people don't know algebra 1 well enough to do algebra 2. Okay. Now, hopefully, maybe in this class it'll be different. We'll be able to go on whatever. You know, the goal of this class is to get you ready to at least take pre-calculus with the support course. Okay. Now, some people come out of this class and skip the support course and take pre-calculus. Okay. Some of them do okay, and some of them really needed to be in that support course because they don't make it. And I have a little bit of both in my pre-calculus course. People are pretty sure are going to make it. People are like, really? Hope they do the MDE 61, but they're good people and they work hard and, you know, do what we can to get them through it. Okay. But the normal progression is you do MDE 60, then you do MDE 61 with pre-calculus. If you do really well in this course, I can tell you, you take MDE 61 if you want, but you're ready for pre-calculus. You still might want to take MDE 61 because you're probably going to do better. And if pre-calculus is really important for your curriculum, you got to take a tough calculus course or something, you probably want to do the best you can. So anyhow, that's kind of where we are in this course. Now, before we get into this, there's a syllabus, read it. And we'll go over it next time. To pass this course, you have to pass the tests. There's basically two big tests, one over algebra one, one over algebra two. Or somehow you have to show me, because I'll be seeing your work. You have to show me clearly that you're ready. Okay? That'll give you a pass in the course. And I think you're ready to at least do MDE 61 with algebra one. I'll probably pass you, depending on the size of the class and stuff like that. I kind of have the freedom to make that decision. Okay. Most people who stick with the class and do the work and show up every day, get the work done, and do the work yourself. Don't let Chang or any other online resource do the work for you, because that's guaranteed that you're not going to learn it. Okay. Most people who stick with it and do all that pass this course. Okay. Most people do pass this course because they do. Most people who stick with it pass the course. Your goal should be to pass the course. It's me telling you, you don't need the MDE 61. Just go right into your calculus. Okay. Okay, so anyhow, okay, now let's get back to basics. Why is 1/2 plus 1/3 equal to 1? Well, there are a couple of reasons, and it has nothing to do with the rules of arithmetic. Common sense, if you know what 1/2 or 1/3 and 2/3 are. Not 2/3, yeah, but you go to the frequently seen model of cut a piece of pie into 3 equal segments. And here you've got 2/3, because each segment, of course, is 1/3. And here you've got 1/3, and clearly 2/3 of a pie and 1/3 of a pie makes a whole pie. Okay. Another way of visualizing it is on the number line, and this is probably what we use more, just a little more compact. Okay. Here's 0, 1, 2. Okay, where's 1/3? Well, we cut the interval from 0 to 1 into 3 equal segments. I didn't get the equal part very well, but that would be 2/3, right? I mean, 2 of these segments would be 2/3. And one of the segments would be 1/3. So if I add 2/3 and 1/3, here's 2/3. Here's 1/3. And lo and behold, that gives it 1. Okay. Now, what you didn't do, well, let's do it this way. 2/3 plus 1/3 then equals. We write it out this way: 2 plus 1/3, okay, which is 3/3, which is 1. That's actually the way I want you to write it out. Now you do it in your head, you know how to do it. It's a little redundant. You want to get in the habit of writing out the detail, because they will come. You know, maybe not till May or something, when somebody makes a mistake. Okay. If you make a mistake, I want to see where the mistake came in. So I want to see the details. Okay. Also, it's just a good habit to get into it because you reinforce the rules. Okay, so the rule is, if you add the denominators and add the numerators and keep the denominator the same, you get the right answer. Okay. Now, what you don't do do that. You're adding thirds. And all of a sudden, here you've got 3/6, which of course, is 1/2. Now, if you add this and this, you get more than half the pie, right? Or if you add this, which is already bigger than 1/2, to this, you're gonna get something even bigger than 1/2. You're not gonna get 1/2. Okay? We don't add denominators ever. So big deal. Never, ever add denominators. Okay. You can't add denominators here, and clearly you can't. And that's not a good thing to do, ever. Okay? Because we have one consistent rule for how you add fractions, which is denominators have to be the same and you add the numerators. That leads us to corresponding common denominators and stuff. We'll talk about that in a minute. Okay. Now, one thing that's a little confusing. Something we do. When we multiply fractions, which is really easier than adding fractions, we multiply numerators. We multiply the denominators. I could demonstrate why in terms of the picture. But we're not going to worry about that just yet. Main thing what point I want to make here is don't confuse this with this. Two different rules, two different reasons. We'll talk about the reason for the multiplication too. Okay, well, with that, we'll complete this. You know what the rule is. You're gonna get 5 + 7 over 8, which is 12 over 8, which is 3/2. Now, another thing, I want to see the improper fraction, like 3/2. Because when we get to symbols, all you got is improper fractions. You don't even necessarily know if they're proper or improper. But when you have numbers, it helps to know that that's 1.5, like if you want to graph it on a number line. It's easier to find 1.5 than it is to find 3/2, although 3/2 isn't hard. Here's a half, here's a half, here's a half, right there. Okay. Okay, well, here, 12 over 7. Now, subtraction is just backwards addition, so the same rule applies. If I wanted to take 1/3 away from 2/3, I'd take one of these away and be left with 1/3, right? Okay, so we got 12 minus 7 over 5, which is 5 over 5, which is 1. And you could illustrate this. Then down here, we get 3 + 5 over 4 equals 8 over 4, which equals 2. And everybody's, I think, got those. Everybody get them? Yeah. They'd look at every mark you know, if I looked at them all, it convinced me that I would have bet money, even against my brother. That you had it right. Okay. Okay. So I'm gonna give you a couple more just to give you a taste of what's coming later. Okay. Well, let's try. X over 4 plus y over 4. So let's try 5 over a plus 7 over a. Okay, so people go through this fairly quickly. X over 4 plus y over 4. I just kind of like 2/3 plus 1/3. You got the same denominator, so you're going to add the numerators. That's going to be X plus y over 4. Okay. Then 5 over a plus 7 over a. That's the same denominator, so you can add the numerators. Give you 12 over a. Now they get more complicated, but I just wanted to break the ice and show you that when there's symbols involved, you gotta think a little more, okay? Okay, good. Okay, well, now we're gonna do the ABC exercise so you don't have to do it. Okay. Question came up, is that an A or an A squared? You could get an A squared if you multiplied these, okay? So we could do like X over 4 multiplied by y over 4. That would give us, you multiply the numerators and you multiply the denominators, the multiplication X difference in addition, okay? We'll talk more about this when we get the multiplication. We do want to understand that. So that could be written as XY over 4 squared. Or XY over 16. If we multiply these, we have five over 8 times 7 over a, giving us 35 over a times a. And so it's a times a is a squared. So we have 35 over a squared. Okay. So contrast the addition and multiplication. Again, you don't want to mix those up. And by the time you complete the assignments, you'll have that pretty firmly in your head. So when we do it later with symbols, it'll be easier. Okay. Okay. Now everybody's got 3 numbers. I've got 3 numbers. I picked a number that was slip out of the hat. And my numbers came out 5, 7, 9. And as I said, I lucked out because I got one of the easiest sets of 3 numbers. I don't even have double digits in any of these numbers. So it's almost within my skill level to add these. Okay. Now, and you got harder numbers, and most people did. So I say that A is the smallest of your 3 numbers, C is the largest, right? So first of all, how we want to identify A, B, and C. So you probably want to write down A equals B equals C equals for your numbers. Okay. But then the first instruction I gave you, this is a fairly complex instruction. I'm just trying to see how we do with reading instructions and so forth. D is the smallest number you can get by adding different numbers from the set A, B, C. Okay. So what's that mean? We've got to add different numbers. They got to be in the set A, B, C. So my set is 5, 7, 9. So I got to pick 2 numbers from that set to get the smallest number I can get. Okay. I mean, I could pick three numbers. It says add different numbers. So if I'm adding different numbers, there's nothing to prevent me from adding all three, is there? That's not going to give you the smallest. Okay. To get the smallest, we'll take 5 and 7, right? So, in my case, D is 5 plus 7, which is 12. Yours, that's the sum of the two smallest numbers, okay? Now. Kind of repeated instruction here. Next number, E is the next smallest sum, so write down what E is. Now, one thing you could do is you could write out every sum you can get. Okay. So you can just write them out. We got 5 plus 7 is 12. What other numbers are possible? Okay, good. Now, there are other sums possible, but you got two of them. You got this one, you got this one, this one, okay. Good. Okay, so if you got those numbers written down, which one is D, which one is E, which one is F, and which one is G? You might not have G written down, but probably do, so identify it. D equals, E equals, F equals, G equals. Yeah. Very good. So in my case, and this is the way I would write it down. And this is the way I want you to write things down when you do things. Don't just write down the answer, write down how you got it. Okay? You really need to do that throughout any mathematics course. Because your goal is not to get the answer as fast as possible, it's to get the answer in a way that you understand it as well as possible. On tests. Camera just went blurry. On tests. My picture. This picture usually straightens the camera out. On tests, you don't want to write down just the answer. Because I don't really grade answers as much as I grade process. If you write down the wrong answer, if I said, show me all your steps, it's wrong even if your answer's right. Unless it's an answer that's really, really hard to get any other way. Okay? Most answers are fairly easy to get in a variety of ways. So in order to get partial credit, you got to show me. Okay, I got to see where you went wrong to see how you were thinking. And up to the point where you went wrong, and maybe even past the point where you went wrong, I can give you credit because you're thinking right. But you had that one little glitch there that threw your answer off. Okay, so you gotta show me what you do. Okay, well, let's see. Camera's back and forth, it looks like it is. Okay, e to the next smallest sum. Well, I could write out possible sums. I might see that the next smallest sum would be the next smallest with the two numbers and so forth. And most people are going to see that, but in solving mathematics problem, there are different approaches. One approach is to identify it. Another approach, maybe you just don't see that, but I think everybody does. You just write out all possible sums. Okay, in this case. And we would say, okay, well, we got 5 plus 7 equals 12, 5 plus 9 equals 14, 7 plus 9 equals 16. And we also have, as I said, sums of numbers. I didn't say sums of just two numbers. Okay. So I could write out these sums, and then I could notice that, okay, E is the next smallest sum. So let's see, D is this. Now, once we understand this, process, you don't have to remember D, E, F, and G. All you got to do is remember A, B, and C, because it just takes a minute to add them up. Okay. Now, the reason this is important is you're going to be using your A, B, C, D, E, F, and G numbers throughout the course. Okay. Quick example, because we're out of time. Here's an example of how you would do it. If I write this with backward apostrophes before and after the numbers, or after the symbols, that means this stands for your A number. Okay. Now, if I write A without the backward apostrophes, this means a symbol A. Okay. So if I write with backward apostrophes, it means we replace this with the number. Okay. So in my case, A is 5. F is 16. B is 7. Okay. And if I give you problems on a quiz in class, a lot of times they're going to be written out like that. So everybody is working a different problem, a different version of the same problem. Okay. So you're going to need to know your A, B, and C numbers. Then you're going to need to know how to get your D, E, F, and G numbers, or you just memorize your D, E, F, and G numbers, whichever is easier for you. You got to have those numbers, and they've got to be consistent. Okay. So when I make up a problem, I know what the order of the numbers is. I know what numbers add up to other numbers. So I take that into consideration when I design the problem. So those are ABC numbers. That's how they're going to be used. And we'll go over that next time. We'll give you a brief explanation. But right now, you got to write down your ABC numbers someplace where you're never going to lose it. Because you're going to lose that little slip of paper.